I was just going to record a short video doing a couple graphing examples. We'll start with a log one. If you remember, a log function always has a vertical asymptote, and it really starts at your y-axis, unless your transformation rules move it. We'll kind of see in a sec that's going to happen in this problem. But so first thing you do with a log function, I would just take the base up to the power, get some points. Sorry, my handwriting is atrocious with my mouse, but you could always plug in 0, that would give you 1. If you plug in -1, that would give you 1/5, the reciprocal. If you plug in 1, that would give you 5. So since we're looking at log functions, this is only something you'll do for logs, is since we're not trying to graph 5 to the x, we're not trying to graph the exponential form, we're trying to graph the log form. So that's the inverse of these points. So we got to swap these around first off. And now we got to look at what rules are going on. So remember, on the inside of your parentheses, or if it's part of your argument, that's going to be a horizontal translation, and it's the opposite of what you would expect. So a +7 on the inside really means to go left 7. If there's nothing in this problem, say you saw something like it was +2 on the outside of your parentheses, that would mean to go up, or if it was a minus, you would go down. Just a heads up if you saw something like that. But okay. So we're going to go left 7. So one thing we need to think about, though, if we're moving this whole function left 7, that's not only going to move our points, that's going to move our asymptotes. Now our asymptote moved left 7, but we got to apply it to these points we came up with our table. So when you go left 7, that's just going to affect your x values. So like 5 minus 7 would now be -2. 1 minus 7 would now be -6. 1/5 minus 7 would be -6 and 4/5. But like I said, you could probably not plot that point if you don't want to deal with a fraction. I mean, 2 points in theory is enough as long as you can see which way it's going with your asymptote, but get as many points as you need to on your quiz. But we'll plot, I'm going to focus on plotting these. Well, this in Delta Math, it just has you do 2 points anyways, and it kind of draws you for it. But it would be -6, 0. And it would be -2, 1. So I mean, like, I know like it draws it in for me, but I can see like as it goes to the right, it's getting bigger. So keep going up. And even if I couldn't plot this like exactly, like -6 and 4/5 would be like really close to the asymptote, and it's going to be down a bit. Like you're going to kind of, it should guide you a little bit. And that would be it for like obviously the Delta Math. I mean, you'd be doing it on paper. I wanted to look then at an exponential function really quick. Clear this really quick. Let's do a little bit more. This would be okay. Okay, so I was trying to find one I think that's similar to what you'll see. So for this, similar idea, I would just kind of ignore the extra junk, just focus on 5 to the x. So like we would have our same points, like, I mean, plug in 0, you get 1. Plug in 1, it's going to just be what your base is. Plug in -1, it's going to be the reciprocal. I mean, you're welcome to do as many points as you like, but that should be plenty. So we don't have to do the inverse though, because we're not graphing a log function. So we do want to graph this exponential form. So we don't want to like flip our x and y, like that would be silly at this point. But if we look at our rules, a negative in front, that means we're going to reflect over the x-axis. It's about as good as I can do. And your exponent is your horizontal translation. So a plus in the exponent would actually mean left 4. We don't have anything in this problem, but if there was something like added at the end here, that would be like if you go up or down. If you remember with exponential functions, sorry, I should have started with this. You start with a horizontal asymptote, and it starts on the x-axis. So unless your transformations move your graph up or down, that's not going to change. We're going to see our rules aren't going to affect our x-axis. If I reflect this, I mean, it's already on the x-axis. And if I move it left, It's not going to change where it is. I mean, if you move a horizontal line left, it's still in the same horizontal position. So we're going to go ahead. We're going to apply these rules, though. If you remember, when you reflect the x-axis, what that's going to do, that changes the signs of your y values, because that's like what would flip it over the x-axis. And then we want to go left 4. So that's my x values. I'm going to subtract 4. So now that would be like -5. That would be -4. And that would be -3. And now these are my points to apply. Like I said, we're not swapping the x and y's. We're not doing the inverse. So obviously in delta math, I'd want to just graph the nice points like -4, -1's down here. We'll do -3, -5. That would be down here. You can see it kind of draws it in, but even with just 2 points, I mean, you should see it's going down this direction. But as it goes up, it's always going to get one side of your asymptotes, or one side of your graph is always going to get close to your asymptote. So usually 2 points might be enough. A question like this too, exponential functions are something you can put in your graphing calculator. You just want to be careful with your signs. Like you want to, the negative is really going to be in front of a question because the negative's not being raised to the power, just the 5 is. And then when you do your power, do like the caret button, but make sure you put the exponent in parentheses as well. You could also like put this in a graphing calculator, go to your like second graph to get your table, and you could pull out a couple points. You would see these 2 points and maybe some other nice ones perhaps. But that's an option for these as well. But hopefully this helps. I'm sorry for not getting this up sooner. We have some training after school yesterday, so I didn't get a chance to kind of record this. But let me know if you have any questions. I can end this.